So when the rocket engine is fired, the flow accelerates and it develops after a while, and it settles down for a smooth cruising speed. That's what we see in number of flows, that it develops after a while. So such flows are called transient flows. The term periodic then refers to the kind of unsteady flow in which the flow is oscillating between the mean point, or what we call as a steady mean. So that is oscillation that we see that a flow a number of times. Many devices such as turbines, compressors, boilers, condensers, and heat exchangers operate for long periods of time under the same conditions, and they are classified as steady flow devices or machines. So as we have seen, that in such flows which remain in the same form after long time, after even running for, let's say, 3 hours, 4 hours, or whatever length of time we make them use of them, then, and they don't change, the flow doesn't change, they continue moving in the same way, then the type of flow is known as steady flow. It's important to differentiate between all these terms, because when we model our equations, when we analyze fluid flow conditions, these things are important. We apply them. They have very significant effect on how we choose boundary conditions, how we choose other initial conditions on solution of equations, which is going to predict the flow conditions after, let's say, some time t. So these differences, if we understand the physical phenomena properly, then its mathematical modeling and its solution also becomes that much clearer, accurate, and better. Note that the flow field near the rotating blades of a turbomachine is of course unsteady, but we consider the flow field rather than the details at some locality when we classify devices. It is something like this. Let us say, for example, if a fan is rotating, then in the neighborhood very close to the fan, the fluid flow condition will be different. But overall flow of air at a certain distance and after a while will be moving in a rather smooth manner. So these things are overall consider the condition, and in where there are some problematic area, we keep it out of our consideration. We will see these things when we solve the equation, when we solve specific problems. During steady flow, the fluid properties can change from point to point within a device, but at any fixed point, they remain constant. Therefore, the volume, the mass, and the time, and the total energy content of a steady flow remain constant in steady operation. So we, as I said earlier, the things that are going to change with time are the volume, the mass, the total energy, which is involved, the velocity, and so on, and of course the distance. Then all these things, if they remain constant, the flow is considered as steady. Steady flow conditions can be closely approximated by devices that are intended for continuous operation, such as turbines, pumps, boilers, condensers, and heat exchangers of power plants or refrigeration. Some cyclic devices, such as reciprocating engines or compressors, do not satisfy the steady flow conditions, since they flow at the inlets and their exits is pulsating and they are not steady. However, the fluid properties vary with time in a periodic manner, and the flow through these devices can still be analyzed as a steady flow process using time average values of the properties, meaning thereby that in the initial conditions a fluid flow may be unsteady, but we consider the time average, the long-term perspective, and then we look for a solution of that type which apply only to the specific type of flow that has been considered and solved with the equation. So at this time, we are pointing out these things so that we understand the differentiation between different aspects of flows that will be considered and where these conditions are applied. Most of the analytical and computational examples that we shall be discussing will deal with steady or time average flow, although we occasionally point out some relevant unsteady flow features as well when appropriate. So most of the time, or in practice, most of the time that the problems that we consider are steady. That helps us in two ways. Well, one, that is the reality in the situation, and also when with time the velocity vector or density or some other things become zero, partial work with time, then it becomes easy to solve complicated mathematical equations that we have to solve and also to predict the flows. But then there are many cases where the fluid flows are steady. It is then difficult to even solve them because it adds a level of difficulty in the equations of motion and their solution.